Alright guys, today we talk about the part of the deposit of the user inside of BitVM. Another way to talk about this, another term is the peg in. Bitcoin doesn't have covenants. That means that it's impossible for one transaction to decide the outcome of the next transaction. In other words, it's impossible for the deposit transaction to determine how the withdrawal transaction will work. I'm talking about those two transactions here. We have a deposit transaction that has inputs and outputs, and then there is a withdrawal transaction that has inputs and outputs. And if you remember, assuming everything is going good, there is also another transaction that is in the hands of one operator that has basically accept the proof is in income as input as witness, and has as output a connector, and assuming everything goes good, the connector is one of the inputs. The other input the output is the amount of Bitcoin to operator. But this is the peg out. For the peg in, we have a specific kind of transaction. We have that the user Alice will put an amount AMT of Bitcoin inside the bridge. And the output is this kind of transaction. It has two branches, branch 1 and branch 2. And branch 1 basically has as output script a hash of a secret. Alright? So that if you put the secret S transaction is valid and money goes to Alice. But it also have another branch, which is after time lock, let's say delta. We need n signatures by the senior committee to move amount to the bridge. And this is n of n thing. And so this is the two branch transaction. What's happening here is that if Alice before time delta thinks that she actually doesn't want money inside the bridge, she can literally block the deposit by using branch 1. So she gets money back. On the other hand, if she actually wants the deposit, she can just leave money there. Then what's happening here is money has moved into the bridge, but will they be minted by the signer committee? And here is the difference between a bridge for Bitcoin and Liquid or a Bitcoin and Ethereum. In theory, they should do the same thing. Let's say we have a bridge between Bitcoin and Ethereum. Everything happening here is in BTC. And after that thing is done, You go to Ethereum and you have Alice posts the transaction done and authorized minting. Now the details of this are murky, but the point is that there is a smart contract. So in a way, this is trustless as long as you trust the validators on Ethereum. Well, at least posting the transaction there means the transaction unlocks new coins, mint new coins for Alice. You need a smart contract. But if you don't have the smart contract, you are relying on something else. It may be the committee unlocking coins for you, and in this case you have to trust, or you may have like some kind of fake smart contract that actually acts as a smart contract. Like in Liquid you can use simplicity to have this kind of thing. And even if you cannot do that with Bitcoin script on Liquid, you can still use simplicity and having a smart contract like that. So let's call it a smart contract. And so this is how you can achieve trustless minting in BitVM.